Hello everyone, welcome to my channel Prokin Academy. Now today I am going to start the class 11 classes. Okay, so first chapter that I want to start here, it is the atomic structure. Okay, now before starting, I want to tell you about the history of atomic structure. Okay, but here the class 11 class atomic structure is starting with the Bohr's atomic theory. Okay, from here you have to start, and the chapter is very long. This chapter is very long, so we have to just normally 5 or 6 minutes we have to learn the history of atomic structure. Now how this the name atom, and actually how the concept came, actually why what is atom, so those things you have to learn here. Okay, now that is the history of atomic structure. Now in ancient India, first in ancient India, Indian philosopher Connaught first told that every matter consists of small teeny particles, and he said about the Anu and Paramanu. He said about the Anu and Paramanu, concept of Anu and Paramanu. Okay. After that, Greek philosopher Democritus told that smallest particle of a matter is called atom. Okay. After that, John Dalton, is given one postulate, that means 4 postulates are there in the Dalton's atomic theory. There he has told that atoms are the smallest indivisible particles of an element or of a matter that cannot be created and cannot be destroyed also. Okay, this is the number 1. Number 2, that means these atoms are not independent. Okay, these atoms are not independent and they are indivisible particles. Okay, number 2, he said that atoms of similar element will have similar property. Okay, atoms of same element will have same property, and atoms of different element will have different property. Okay, that means atoms of oxygen will have same property. All the atoms of oxygen will have same property, and all the atoms of nitrogen will have the same property as nitrogen. This is number 2. But the atoms of different element will have different properties. That means the property of oxygen atom is not similar with the property of nitrogen atom. Okay, that is the third postulate. And number 4 postulate is said that whenever during the chemical reaction, these atoms will combine with each other as an integer value. That means 1 atom of oxygen and 2 atom of hydrogen to form the water molecule. Like that, they will not form as a fraction. So this is your Dalton's atomic theory. Okay, but what he has said that atoms cannot be destroyed, but atom can be destroyed. That means atoms can be made of some particles. Those particles are the electron, protons and neutrons. Those particles are the electron, protons and neutrons, and some other particles may be there, positrons should be there, can be there. But these 3 particles, electron, proton and neutron, these 3 should be there. That means these are the subatomic particles. So some of the scientists came and they told atoms should be made of some particles. They should be made up of neutron, proton and electron. Okay. After that, William Crookes has made one experiment. Okay, and from that is the Cathode Ray Experiment, and from there he observed that one ray will go from cathode to anode. This topic I will discuss in another video. Just let me say this one, that indifferently I will discuss. Okay, this Cathode Ray Experiment. Just now I am telling that one ray will go from cathode to anode. Okay, and that as the charge of cathode is negative and the charge of anode is positive, so the ray which is going from cathode to anode must consist of negative charge. Okay, that means that the flow of negative charge is nothing but the electron. So from there we know the concept of what is the electron. So electron can be there in the atom. Okay. After that, J.J. Thomson just observed the electrons are there in the atom, and he just discovered the electron. Okay, J.J. Thomson discovered the electron. Okay, after that he has given a model. He has given a model that is a palm pudding model, and in that model he told that the structure of atom will be circular. The structure of atom will be circular, and in that circle, positive charge will be spread. That means spread out the positive charge. That means photons will be spread out throughout the circle, and in that negative charge will be there. That means electrons will be placed in such a way, same as the palm pudding. Palm is placed on the pudding. Okay, same thing. That model is called palm pudding model. But it is not possible that electrons will be placed in between the photons. It is not. So it is not like that. So it cannot explain the stability of the atomic structure, which is further shown by the Rutherford. Okay, so this theory is not proper applicable. Okay, and after that, Rutherford came and has changed the structure of an atom by his alpha ray, that means alpha particle gold foil experiment. Okay, and from that experiment he told that he has observed some 3 observations, and after that he has taken 3 conclusions, and that is the main thing. Okay, that he told that the structure of atom will be circular, and in the middle of that, one heavy mass will be there, that is the positive, and there you will get the negative proton and neutron. So in the circle, that means if the structure of an atom is circle, then at the middle, okay, nucleus will be there, which consists of proton and neutron. Nucleus will be there, which consists of proton and neutron. Neutron will be neutral in charge. Okay, and in the surrounding this nucleus, electron will be there. So that is the main your atomic structure. Now the idea of the neutron was put forward by the Rutherford only, but the conclusion is done, that means a neutron is there in the nucleus, is done by the Sedgwick, Rutherford student Sedgwick. So this is the total history of atomic structure before the Bohr's theory. So Rutherford, two drawback was there for Rutherford atomic theory, that he is telling that electron will revolve around the nucleus. But normally, according to electrodynamics theory, if electrons are negatively charged particles is rotating around the positively charged particle, so there will be electric attraction force. So what will happen? The pathway around the electron is rotating. Okay, one time will come, if it continuously releasing energy, one time will come when the energy of the electron will be finished. That means it will be less. So that time the electron will fall on the nucleus. So that will not explain the stability of an atom. Okay, so this is the drawback of Rutherford atomic theory. And again, he compared the Rutherford atom, that means structure of an atom, with the solar system. So that is also the drawback of Rutherford atomic theory. So to correct this theory, Bohr came and has given one theory. That one will start here. Okay, just 1 minute. Let me check it is going on, and the video is going on properly or not. Okay, so what I am telling that this is the drawback of Rutherford atomic theory, that if electron continuously releases energy, then the pathway it is revolving the nucleus. Okay, it will form in the same pathway to the nucleus, like a spiral pathway. So that will not explain the stability of the atom. So this is the drawback of the Rutherford atomic theory. So after that, Bohr came. That means he has given one revolutionary theory, that means scientist Bohr, and those postulates we will discuss here. Okay, in this video, that he has told that so many orbits are there. Okay, around electron will revolve. Okay, so around nucleus, electron will be revolved in different orbits. So many infinite number of orbits are there. Okay, but infinite number of orbits may be there, but electrons will revolve around those orbits. Okay, he has told that electron will revolve around those orbits where the angular momentum of the electron okay, in that orbit will be quantized, so in those orbits electron will be revolved. Now what is the meaning of quantized? Okay, that means it will be integral multiple of h by 2 pi. Okay, and those orbits will be called as stationary orbits. So out of infinite number of orbits, electron will revolve in those orbits where the angular, okay, this one is very important, angular momentum of the electron is integral multiple of h by 2 pi. Now here h, the term h is coming from the quantum theory. That means h is nothing but the Planck constants. Okay, h is nothing but Planck constant, and its value is 6.626 10 to the power minus 34 joules second. So it is a constant. Okay, now here, so those orbits will be called as stationary orbits. So electron will revolve in those orbits where the angular momentum of the electron will be integral multiple of h by 2 pi. Okay, and those orbits will be called as stationary orbits. Okay, and those orbits will be regarded as energy states. Okay, and the energy of every electron, okay, which are present in a particular orbit, okay, will be constant. That means in a particular orbit the energy of the electron will be constant, and that means it has a different value. A particular orbit, electron has a particular kind of energy, okay, and that will vary with the orbit to orbit. Okay, that will vary to the orbit to orbit. So he has named those orbits as K, L, M, N, like that. So electron will revolve in a circular orbit. Okay, the orbit will be circular. I think you have written this one. So electron will revolve in a circular orbit. In the center, nucleus will be there, whose charge will be positive, because in the center proton will be there, and the number of proton present in the nucleus is the atomic number. Okay, and as the charge of the neutron is neutral, so the charge of the proton represents the charge of the nucleus. Okay, and different orbit electron will revolve. In different orbit electron will revolve. The first orbit from the nucleus is called K orbit, and it is the first orbit. Okay, it is the first orbit, and it is the first energy state. Okay, second energy state is L, then third energy state M, so on. Okay, K, L, M. He has named the energy states as K, L, M. So this is the first, and this is the ground state energy level. The first energy level K, that means orbit, K orbit, is represents the energy level, because this, if an electron is there in the K orbit, it will have a particular energy. So this shows the energy state. So this is the ground energy state. Okay, the first, this one is second, this one is third. Okay, now if an electron is revolving in a particular orbit, say it is revolving in K orbit, say the electron is revolving in K orbit, in this K orbit. So as it is a particle which is moving in a circular orbit, so it will have a mass, it is m. Okay, and it will have a velocity also, and that will be tangential velocity, that will be v. The tangential velocity will be v, and the radius of the atom, it is nothing but the distance from the nucleus to the electron. So this is the radius. Now as the particle is moving in a circular orbit, so it will have a momentum, that will be angular momentum. Now angular momentum is nothing but mass into velocity into radius. Now Bohr told that the angular momentum will be mass into velocity into radius, angular momentum, and it will be integral multiple of h by 2 pi. Now integral multiple means we have to take an integer, that is n, and whose value may be 1, 2, 3, anything, and this shows the number of the orbits. If the value of n equal 1, this shows the k orbit, that means first energy state. Okay, this shows the second orbit, that is second energy state, third energy state. And here when we learn the quantum theories, just we will learn the quantum theory in different videos. Okay, so you will combine, you can relate. So there I will tell you that this n is nothing but a principal quantum number. Principal quantum number. Now here it is showing the energy state. It is showing the energy state. Okay, so and it is an integer. So it will be NBR equal NH by 2 pi. Here n is integer. N is an integer whose value is 1, 2, 3, anything, and it represents the number of the energy states, and it also represents the principal quantum number. So the value of the n represents the principal quantum number, and these are nothing but the number of energy state. That means for first energy state, that means for k orbit state, for k, the angular momentum will be mass into velocity of into radius of the electron into 1 h by 2 pi. Why 1? Because it is n, the value of n equal 1 for the k orbit, so 1 h by 2 pi, and h is nothing but time constant I have told you earlier. For next orbit 2 h by 2 pi, for third orbit 3 h by 2 pi. Like that it will go. Okay, so this is the first postulate of Bohr's theory. Now again Bohr told another one, that how many maximum number of electron can be present in a orbit. That can be calculated by the rule 2n square. That means in the first energy state, in the first energy state, the value of n equal 1, so we'll get 2. So in the first energy state, that means k orbit, the maximum number of electron can be present is 2. For second energy state, that means for k it is k. For L orbit, the maximum number of electron can be present, it is 2 into 2 square, that is 8. For M orbit it is 18. For N orbit it is 32. So the whole concept is given by the Bohr. I think you have understood. Now the second is that Rutherford said that whenever electron is moving in a circular orbit, it will continuously release energy. But Bohr corrected this one, is in second postulate, that whenever as long as the electron is in the particular orbit, rotating the nucleus in a particular orbit, it will neither gain energy nor radiate energy. Okay, whenever an electron is rotating in a particular orbit, it will neither gain energy nor radiate energy. Okay, the second postulate is that electron would not absorb or radiate energy as long as it is revolving in an orbit. Okay, it will not radiate energy nor absorb energy. But whenever an electron is jumping from one energy state to another energy state, it will release or absorb energy. So when electron is going from lower energy state to higher energy state, that means the ground state to the excited state, the higher energy state will be called as excited state. So whenever an electron is going from lower energy state to higher energy state, it will absorb energy. Okay, lower to higher energy state, okay, absorb energy. Okay, whenever electron is going from lower energy state to higher energy state, it will absorb energy, and whenever electron is jumping from higher energy state to lower energy, it will release energy. Okay, and the higher energy state will be called as a excited state, and the lower energy state will be called as a ground state. Okay, so this is the overall Bohr's atomic theory. So next day we will discuss about what is the energy of the electron which present in a particular orbit, or what will be the radius of that of the orbit, okay, from the center of the nucleus, center of the atom. So we can calculate those things, and those are very important. So from next video I will discuss those things. So today is up to this. So if you like this video, then do like, comment and subscribe my channel. Thank you.